Okay, welcome to another video on solving quadratics. Today we're going to be covering another method, or at least the start of another method for solving quadratics. And again, two main ways, algebraically and graphing. Graphing, look for intercepts after you graph it. Algebraically is what we're focusing on right now, though. Previous ones that we went over before, we've been over factoring, we went over square roots. We're going to start completing the square now. Now, this video does not show how to solve using completing the square. This video, that's the next video. This video is just going to show you what completing the square actually is. So, the process of completing the square. Kind of like if I showed you a video on how to add numbers, but that doesn't necessarily mean I show you how to solve using addition. It's just showing you how to add. So completing the square is a process. We're later on going to use it to actually solve. But for now, let's take a look at previous lessons. I'm going to combine two previous lessons together, so it's not necessarily a new thing, but it's going to be using things we had in the past. Okay. Previous lesson on solving using square roots, if you remember, if we had something being squared, we could go ahead and just take the square root of this thing. So you square root both sides. You have a plus or minus of that square root. Once you have the plus minus, you separate into a positive and a negative. Take the square root of 25, you get a 5. Then you subtract 6 and you get negative 1. This side, you get a negative 5 because square root of 25 is 5. Then you get the negative, and then subtract 6, you get a negative 11. Okay? Now, like I said, that was from a previous lesson, so if that was kind of fast for you, go ahead and watch the previous lesson to kind of get caught up with that. Now, we're going to combine this knowledge with knowledge that we had in the past about factoring patterns, because solving like this is not too bad. So what we're going to do is, what completing the square does is it turns a problem where you previously could not use square roots to solve and turns it into a problem where you can use square roots to solve. So for example, this one, previous lesson review, factoring patterns. When we had factoring patterns, this was a perfect square trinomial. If you had a perfect square in front, perfect square in back, that's a 4 because 4 times 4 is 16. This is an x because x times x is x squared. Then 4 times x, double that, you get that 8x. So technically you can just turn this into this, okay? Now, we don't even got to check to make sure the pattern works for completing the square because we are going to make this pattern from scratch, okay? So we are going to make sure that the trinomial that we get, we can just turn into x plus 4 squared. Basically, you just figure out the square root of the front and the back, x and a 4, and then copy the sign here and square that, and then you don't got to do any of those factoring steps that we did in the past, okay? All right, so this is a visual model of completing the square using algebra tiles, which we've used a lot in the class now, so hopefully you still remember what we did with these. So this is called a single unit. Use those for your singletons. This is your x, so you use that for any of your x linear variables, your x unit, and then x times x is your x squared unit. So we use this for any x squareds that we want. So for example, if I showed you x squared plus 2x, this would be one x squared tile and then two x tiles, okay? So this is x squared and then two x's. Now, completing the square, when you think about it, it has in the name, how do I make a square out of these pieces? So normally in class, I'd have you rearrange these, kind of see if you can make a square out of this. And most we can make is like a rectangle. This is almost a square, but we're missing a piece. Maybe if I slide them both to the same side. No, that still doesn't work. So turns out I cannot do this. We are missing a piece of a square. This is the closest that we came. These two sides are the same lengths. This would be the same length if we weren't missing that piece. So the process is called completing the square because you're actually going to make your own square. So the question becomes, what other piece of algebra tiles do we need to make this into a nice, neat square? So turns out what we need is a singleton piece. We need a 1 because that would fit nice and neatly right there. So I'm going to add a 1 onto my expression. And there you go. I just completed my square. That is now a nice and neat square. Now, the fact that I made this into a perfect square trinomial, now I can use my pattern. Square root of 1 is a 1. Square root of x squared is an x. And there's a plus sign. So it's going to be perfect square trinomial, x plus 1 squared. Square root of 1 again is a 1. Square root of x squared is an x. And then you just throw a squared on there. All right. So let's try this with another one. Again, I have an x squared tile. I have 4 x tiles. Now, what I'm going to do is you shouldn't be putting these X tiles all over the place. Just line them up on two of the sides, all right? So there you go. This is almost a nice, neat square. I'm just missing this chunk in the bottom right-hand corner again. How many pieces do I need to fill that in? Looks like 4 pieces would be nice and neat there. So there you go. I just completed my square again. And again, this is now a perfect square trinomial. I just completed a perfect square. So square root the front, square root the back. Square root of x squared is x. Square root of 4 is a 2. There's a plus sign in the middle, so x plus 2 squared is what that is. All right. And let's try one more. So 8x's. So I'm going to take those 8x's and again start looking at this process because we're not always going to use these algebra tiles. Obviously 8's already becoming a lot if you're supposed to draw these out. Basically, in order to make a perfect square, I got to make sure everything's nice and even. So I have nice neat squares on the side here. And then I have my 8x, so x squared plus 8x. Now I'm going to go ahead and figure out what goes here. Now, there's a lot more going on here. So if you think about this, this is 1, 2, 3, 4, 1, 2, 3, 4. This is a 4 by 4 square down here. So 4 by 4, that's going to be 16. Okay, so I need 16 pieces to fill that in because it's a 4 by 4. 4 times 4 is 16. That's like in elementary school when you used to do area models, that's how you used to do that, right? I now have a perfect square trinomial. Square root of x squared is x. Square root of 16 is a 4. So I got my x plus 4 squared. Okay? All right. So next example, x squared plus 10x. Again, we have 1x squared. We have 10 x's. So what we're going to do here is, like last time, we're going to go ahead and split those 10 x's into 2 groups. That way we can have nice, neat groupings on both sides and make a perfect square. And again, once we split the 10, we have a 5 by 5 square here. So 5 by 5, 5 times 5 is 25. So it should be a 25 square block that fits inside of there. 25 little pieces there, so 5 by 5. And there you go, perfect square trinomial. Square root of x squared is just an x. Square root of 25 is a 5. You get a plus sign, so x plus 5 squared. All right. So the question now becomes, these are all the ones that I just showed you. If I don't have algebra tiles in front of me, what exactly are we doing with these x numbers that we can make these other numbers over here? So basically, take a look at these and see if you can figure out, okay, what did we do to the red numbers? Or what can we do with these red numbers to get these green numbers if I don't have a bunch of algebra tiles in front of me? All right, and then think about the process that we did. Now, if I go back to the process that we did, let's say we had x squared plus 10x. Our first step was that we divided it by 2 because we needed 2 groups. So we took this 10x, and I took just the 10 part. I don't really need the x part. I just know I have 10 of them, and I divide it by 2 because I need 2 equal sized groups. So your first step is just to take your x and your b term, so ax squared plus bx plus c. Your b term that's in front of the x, you divide it by 2. Okay, and then I get a 5. So, okay, now what do I do with this 5 in order to actually get the number? And if you think about it, this 5 represented the lengths of this little blank square down here. So what did I do with the 5? I did 5 times 5, and I got this spot down here. Well, 5 times 5 is the same thing as 5 squared. It's a square. That's basically like the literal meaning of it, is you square it. So then you get a 25, and then that would fill that in. All right. So basically what we did was we took this part, the x part, divide it by 2, and square it. So we divide it by 2, and we got these parts, and then we square it. And that's the process of completing the square. So, and then you can go ahead and factor it into that, and we're going to use that in the solving pieces. So let's say that I gave you this one, and we don't have algebra tiles, and I wanted to know, hey, what are we adding on to this end right here? What do I need to add to make a perfect square trinomial? So you take your linear term, the term next to your x, just the 16, I don't need anything else. You divide it by 2, and then you take that and square it. So divide by 2 and square it. Okay, so again, you just, doesn't matter what the number is there, you divide it by 2 and square it. So 16 divided by 2 is an 8. 8 squared is 64, so that must be a 64. Now, taking a look at this, obviously there's some instances where this is nice, there's some where it's not. So for example, if this was a 5, this process would get a little bit more difficult because 5 divided by 2 is not a nice neat number like an 8. But you can still square 5 over 2, you get 25 over 4, and that's what you would add on, okay? And then you just use your pattern, x 64, so x in an 8 and squared, and that's all. Okay, that's the completing the square process. So this right here is basically what completing the square is. All the algebra tile stuff was just to kind of show you visually what it means. All right, so let's take a look at this one. Let's do one more example, and then your homework is basically going to be just completing the square like these. This one is a little different. I have a negative 22. But basically, you still divide by 2 and square it. So I'm going to take my negative 22. I'm going to divide that by 2 and then square it. So negative 22 divided by 2 is negative 11. Squared is negative 11 times negative 11 is positive 121. So you're going to notice that no matter what this term is, it's positive or negative, you're always going to be adding this part on, okay, to complete your square. And then for the factoring, x and then 11, there's a minus sign here because this part was negative. So whatever this part is, whatever this part is, that's going to be there. Now, if you notice, it's actually going to be this step right here. Right after you divide by 2, whatever's inside of here, that's what's going to be inside of there. Okay. So go ahead and try out the worksheet. Let me know if you need any help. And I hope everybody's doing well. Okay. Bye-bye.